Okay, welcome back. We got a Toyota Prius hybrid battery. It's had one cell that was bad. Before I start tearing everything down and charging the battery up, since I've already cycled using an iCharger 306B, I'm going to start just checking the cells again to make sure that I didn't miss one before I tear it down and have to find out that I need another cell put in. So this is slightly boring, but useful information. You want to make sure all the cells are within the same specs, voltage wise. That one's good. 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 Let's see here. Good battery. Another good battery. Good battery. Normally when they die, you just lose one cell. But occasionally you have more than one cell that goes bad. Or your whole pack dies. Like you see with that one there. Yeah, see, there we go. I've got one right now I'm working on that I've tested the entire pack for 2 weeks now, and the battery does not get any better capacity wise. It's a 6.5 ampere per cell module. It's like a 0.7 kilowatt hour or something like that. Don't quote me on that, but I'm thinking that's what it is. Anyways, the ampere on this is only a 6.5. This cell is bad, so I've already got it marked. All the voltages are good, so I'll just charge test it after I'm done. But on this battery over here, it's been cycling for about 2 weeks now, and so far every cell on this battery came out to about 2500 milliamps. Voltages and everything seem to be fine, and you always use some dielectric grease on your BMS connector, which is right there. And of course I'll put some on this one here. I always check for corrosion, because you could have a pin corroded on these and not even know it, and put it back in the vehicle and you've got a triangle, even though you just replaced the cells that were bad. Normally these will corrode up, and a lot of times I've noticed that it's the upper pin or it's the lower pins that corrode. The ones in the top hardly ever. You get like maybe 2 or 3 cell connectors that's bad on the cells, and then you got to go through here and clean those out. But a lot of times when you're checking the batteries, I always take everything off, clean all of the bus bars before reinstalling the battery or reassembling the battery. You've got a lot of corrosion on the nuts and stuff on the battery, so I'll take and clean those, and the copper bus bars will be polished before I assemble the battery pack. After I've replaced the cells that need replaced, I'll charge and load test everything again to make sure that they're all within specs. I normally look for anywhere from 3800 milliamp hours or amperes, 3.8 amperes to about 6 amperes on the battery capacity. Anything below 4 is considered to be a weak battery, because you can't fully use the 4 capacity of the battery anymore, which the Prius only yields 4 amperes of the 6. So they don't really worry. As long as you've got 4 amperes capacity on the battery cells, you're fine. But on this one here, being a 2.5 ampere, after it's cycled, I'm going to say each cell has cycled, I think, about 4 times. And on all 4 cycles, they charge and discharge has always been the same. Discharge will be a little lower depending on what you're setting on. I normally discharge at 10 amps and charge at 10 amps. So that gives me an idea of what's going on. And then a lot of times you just have a if you've got a bad cell and the battery's testing good, but you're curious just what's going on with the battery, your engine computer or your hybrid computer that controls the battery and the hybrid vehicle, well, we'll just talk about the battery BMS system, the battery management computer, will actually sense a weak cell before you could actually test it. So as you're driving around, you have a cell that's, when you first test them, I've had this happen. I test them at 10 amps, charge them at 10 amps, discharge and charge. I'll have one that will charge up to about, well, you can load test it, the voltage and everything will work out fine. The battery shows good until you put it in the vehicle. And then, if you monitor it with a graph, as you start braking, you're putting in about 100 amps from the regenerative braking as you're slowing down. And that will actually tell you if all the cells are good, all the voltages will be equal straight across on the line. If you got a weak cell, it will charge fast. Fully, the voltage spikes on it. And it will discharge fast. So if you're driving up a hill, try to drive slow so the engine turns off, and you're loading around 20 to 80 amps normally, going up about a 2-degree incline, which is about normal in most areas. It's about like a driveway, about 2 to 3 degrees. And you want to monitor your cells voltages as you're going up a hill and going down a hill or slowing down. If your voltages are staying near 16 volts, you're fine. But if you got one that's spiking up around 17 volts and the rest of them are like 16.8, you've got a bad cell in the block. And with this battery here, this battery will not be put back in the car. I've already marked it bad because the Prius yields 4 amperes of the full 6.5 amperes from these cells. Because it's lower capacity, it will actually set a triangle light and a code for weak battery or replace hybrid battery. So with that being said, this battery's junk. This battery here is actually testing up good. I've got around 4 to 5.5 amperes on this battery. So all the cells are cycling up. The capacity keeps building as I'm cycling, so that's perfect, which is what you want. You want the capacity to build up over like 4 cycles. If they don't, after you've cycled them 4 times, then that one cell that isn't building up as good is already dying. A lot of times you only have to replace 1 or 2 cells, but you always want to check the charge of the battery and the cell's ability to push out the amperage. So in my testing, I've actually discharged the batteries at 10 amps and charge them while I'm monitoring to see what the voltages are. If they spike above 7.8 volts on a 10 amp charge, right as soon as you just got done discharging it, that battery's weak. So the internal resistance is real high, or real low, which means it's easy for voltage to go through, but it doesn't build up in the battery. It isn't absorbing the charge, so to say. And on these here, they was all absorbing a charge, all within the same capacities, 2.5 amperes. Voltages are good, they test good. The full overall capacity of the battery is very low, and this battery pack is actually fixing to die. So I don't know what year this battery pack is. I'm sure we could probably look up the serial number on the battery. just to see what it is, see what year it was made. But I'm gonna say this is probably a early 2005 to 2008 battery pack, just from the capacity that I've got out of each cell. This one here is actually a pretty newer pack. I'd say anywhere from 2007 to 2010 on this battery pack. So I'll leave it there. I'll come back and actually we could just Google all of this together. I'll look up the year for this battery and see if I'm right. I'm thinking it's lower. It's pretty old, probably a 2005 model. So just look up a VIN decoder for a Prius battery, or actually just type in your it's a Panasonic 17YF 4A13202D and search it. So that's not coming up anything. Of course, that's the problem you have with a lot of this. It's hard to tell what year this battery is. Could be an 04 if the VIN number is right. I'd say it's an 04, definitely. So if you've ever got a battery that's testing good, but you're curious, if you get a check engine light or you keep seeing the battery multiple times, you can't figure out what's going on, you've replaced everything on it, check your capacities on your cells. If they're low, if they are lower than 4 amp hours, the battery is bad. The car will always set a weak battery code no matter what you do to it, because the Prius is always monitoring the battery. It's discharging and charging battery up while you drive. I'm just going to say that if you are curious on if the battery is bad or not, you could turn your AC on 4-speed, 60 degrees, and let your air conditioner run with a full battery. With a full battery, that air conditioner should run for about 15 to 20 minutes. It pours roughly 4 amps from the battery pack, and you should get around 15 to 20 minutes before the engine has to start up to recharge the battery pack. On a fully charged battery, like if you've got a Prius extender charger, you plug it to your mains power, 210 or 115 volts, you'll actually have a full charge battery when you do the test. So you can actually unplug the cord, do the test in the vehicle after the engine's warmed up, and if you're anywhere near 15 minutes or longer, the battery's in good condition. If your engine's starting up and dying and starting up and dying, your battery is very weak, or you have a bad cell. So I would just, if you've got any knowledge on how to test them, or got hobby chargers you can use to discharge them safely, I would start this connector here and pull it off first when you're working on the side of the battery. start on the lowest side of the battery and start pulling these bus bars off. So you're not working with anything above 180 volts. So as you start pulling these bus bars off, you're lowering the voltage overall on the battery. Even though you've got the fuse out of it, it's still safe to work on this side of the battery pack versus the side with the main negative and main positive that feeds your vehicle. If you work on this side, there's no big risk of getting shocked, but just remember, if you work with one hand, you're fine. If you're having to put two hands across the battery pack, do not do that. You could be shocked pretty bad or killed. It's best to use insulated tools or get your drill. Put a nut drive on the end of it. 8mm socket. You don't have to touch anything other than just one connector at a time. So there's no risk of... There's not a big risk of getting shot, but you still have to be careful. Makes life a lot easier taking them apart. You've got one hand on it versus having two hands. Having two hands potentially on the battery pack at one time could shock you, and you don't want to be sending any power across your heart, because then you are no more. So just watch what you're doing. Can't really say common sense applies, because this stuff isn't... If you had common sense working on battery packs, you would have gloves working on these. There's nobody's going to do that unless they're in a factory. As long as you know how to disable the battery from the low end and work your way up, it's fine to do it by hand with a small nut driver. Just keep one hand on the battery at one time until you get the entire bus bar side off, and then you can start working on the other with two hands. But do not attempt to work on these batteries with two hands across either side of the battery pack. Bad things could and will happen if you do that.